your drinking water. Increasing local concerns about dihydrogen monoxide levels led us to dig deeper. And as you'll see in a moment, what we found was, to say the least, troubling. What is DHMO? Well, technically in science, it's a solvent. Its uses are far-ranging in industry and even in some household goods, from certain additives in paints and thinners to use as a cleaning solvent for industrial parts. Indeed, its wide and varied uses may explain why it continues to show up in municipal water systems at alarmingly increasing rates. But is DHMO really dangerous? For years, health and emergency officials have suspected the DHMO reality. Jeff Sorensen is the new township supervisor for Cooper Township, Michigan. Since being elected, he has stepped down from his longtime position as fire chief. Jeff has spent over 25 years in fire and rescue work. DHMO-related emergencies caught his attention over a decade ago.
It is just terrible. Those are the worst calls we run, especially with children. Several calls a year that we run on, and rescues alone, are directly related to DHMO, without a question. It is proven through autopsies that it has been the main cause of death in these related instances.
But despite numerous surveys indicating widespread public support to ban DHMO once people are educated on its dangers, numbers ranging from 62 to as high as 90% of participants in some studies, there are still some in the industry who believe DHMO is safe.
So let's talk a little bit more about DHMO. Do you think it's a very serious threat or just an issue of concern? I found a list of some other things that DHMO is linked to. DHMO, or dihydrogen monoxide, the dangers, uses, and potential threats posed by this chemical are widespread, and some feel very terrifying. Here's just a small taste of what DHMO is. Some call dihydrogen monoxide the invisible killer. Others think it should be banned. It is linked to gun violence. It is found at every school shooting. Athletes use it to enhance performance. It's found in our lakes, rivers, streams, oceans. It's a major component of acid rain, and thousands die each year from inhaling dihydrogen monoxide. It can be deadly. Hi, welcome to Chemistry Unit 3 on naming compounds. This is 3.2. Ionic compounds. In order to name an ionic compound, you first write the name of the element with the positive oxidation number. This should be first in the formula. Then you write the root of the name of the element with the negative oxidation number. You will have to remember your syllabication to know what the root is. Finally, you're going to add a new suffix to the end, an IDE. So all of these will end in "ide," and the "ide" simply means I'm in a compound. So you already have the Roman numerals 1 through 6. The first element, if the first element is a transition element, you have to determine its oxidation. Generally, this will be the subscript of the element that it is bonded to and show it as a Roman numeral. So here are some examples. We're going to look at BeO, CaF2, ZnI2, and NaBr. If we name them, BeO is beryllium oxide. Beryllium, Be is beryllium, first name. O is oxygen, but when it's in a compound, it is ox, the root, ide, the suffix. CaF2 would be calcium fluoride. Zinc 2. Now that 2, this Roman numeral of 2, came from I2. Iodine has an oxidation of 1 negative. Zinc had to have an oxidation of 2 positive in order for them to crisscross to get ZnI2. This is why it is zinc 2, part of the first name, iodide. And finally, NaBr should be sodium bromide. Polyatomic ionics, you're going to write the name of the element or the polyatomic that has a positive oxidation. You're going to write the root of the name of the element with the negative oxidation and add "ide" to it, or simply write the name of the polyatomic. CaSO4, BeNO3, 2, NH4OH, H3OF. Now, some of these you're going to have to be able to figure out what your polyatomic is or where your polyatomic is. So is your polyatomic CaS or is it SO4? Well, you'll have to look at your polyatomic sheet for that, but it is SO4. So this name, first name would be calcium, last name would be sulfate, simply using the polyatomic name. The second one down would be beryllium nitrate, ammonium hydroxide, and then hydronium fluoride. Notice that your polyatomic is the H3O, that's given first. F is fluorine, but in a compound it would be fluoride. Covalent naming. If you're going to name a covalent bond, you're going to give it its first name and last name, but this is more for bonding. If you have to bond covalents together, there are 3 basic rules. The lower group number goes first. The higher period number goes first if they're in the same group. The second element is always named as an anion or ionically, and you're going to add the "ide" to the end. So essentially, every compound is going to end in "ide." The cool thing about covalence is that prefixes are used to indicate the number of atoms of each element, except if the compound has one element as its first name. We do not use the prefix of mono. So here are your prefixes. Mono means 1, di is 2, tri is 3, tetra is 4, penta is 5, hexa is 6, hepta is 7, octa is 8, nona is 9, and deca is 10. These are very similar to your polynomial prefixes in math, except for 2 and 4, they're going to be slightly different, but everything else is pretty much the same. Note again, the only time we don't use a prefix is when mono would begin the name. So no name begins with mono. Examples for this are the compounds of SiF4, N2S3, SCl6, and P2O5. This is going to feel like you're kind of naming dinosaurs. SiF4 is silicon tetrafluoride. Tetra meaning 4, fluor meaning F, ide meaning I'm in a compound. Dinitrogen, 2 meaning di, and nitrogen. Tri is the 3, sulf is the S, ide. Sulfur hexachloride. Hexa is 6, Cl is chlorine. Remove the original suffix, add the suffix of ide. And finally, P2O5 is diphosphorus pentaoxide. This is what you're doing today in class. Good luck. Thanks for watching.